Welcome to all of B.Sc 3 physics students. Now we have started already the topic first, crystallography. Now in this topic, in the previous lecture we have seen the introductory part, brevices, lattice and unit cell. Now in this today's second lecture, we have to study the what is the crystal structure, what are the interfacial angles and so on. So first, interfacial angle, the angle found between a pair of adjacent faces of a crystal. Now here, this is the normal drawn on one of the face, this is second normal drawn on the second face, then the angle made by the two normals of the two faces, it is called as the interfacial angle. Here 40 degree is the interfacial angle between the two adjacent faces. Now what is the crystal symmetry? Here I have shown schematic of one butterfly. The two wings of the butterfly are exactly symmetrical to each other. Likewise, in crystal also there is a symmetry. So it explains how similar atoms or group of atoms repeated symmetrically in space to produce ordered structure. It can be studied with the help of operation that can be operated on the crystals known as symmetry operation. Now, what is symmetry operation? It is an operation that can be performed either physically or imaginatively on crystal with reference to plane, axis, point within its mass. Now, the symmetry operation can be achieved by rotating the crystal in particular axis, by selecting the plane which shows mirror image, by selecting the point which shows equidistance. Now, the first, elements of symmetry or types of symmetry. So in all there are three types of symmetry. One is plane of symmetry, second axis of symmetry and third center of symmetry. Now the first image shows it is the plane of symmetry. Second image shows it is the axis of symmetry. And third image shows it is the center of symmetry. Now see, plane of symmetry. That means if the plane is symmetrical, suppose in the first image the plane is parallel to lower face and upper face. This is the first possibility. Second, it is perpendicular. Third, it is parallel to front and back. So likewise, in all there are 9 possibilities in which the plane is symmetrical. Your idea will be more cleared by seeing these images. So here 3 and 3 and 3. So in all 9 planes of symmetries of the cube. So here more idea will be cleared about the plane of symmetries. Then what is the axis of symmetry? What is actual axis? Axis is nothing but it is a line about which the crystal may be rotated so as to show the same view of the crystal more than once per rotation. That means if we rotate this cube with respect to this vertical axis, then the different face will come to the front side. So how many times the faces will come to it indicates the axis of symmetry. Then see here, in all there are 4 axes of symmetry, 2-fold axis, 3-fold axis, 4-fold axis and 6-fold axis. So what is 2-fold axis? On the rotation about the axis, if the same face or same view occurs 2 times, then the axis is termed as diad axis, that is the 2-fold axis. Then on the rotation about the axis, if the same faces or same views occurs 3 times, then the axis termed is triad axis or 3-fold axis. On the rotation about the axis, if the same faces or same views occurs 4 times, then the axis is termed as tetrad axis or 4-fold axis. And last one, on the rotation about the axis, if the same face or same view occurs 6 times, then the axis is termed as hexad axis or 6-fold axis. Then this indicates, here I have shown one typical example, 4-fold symmetry axis. This image shows 3-fold symmetry axis and this image shows 2-fold symmetry axis. And this table indicates the symmetric characters. That means the plane of symmetry, Then axis of symmetry 6, 4, 3 likewise. Now, so what is the center of symmetry? This red point indicates the center of symmetry. So it is the imaginary point in the crystal, and that any line drawn through it intersects the surface of the crystal at equal distance on either side. So center of symmetry is the point from which all similar faces are equidistant. So with respect to this red point, all the faces of the cube are equidistant. Now, we have to study the crystallographic axes. We know there are the three axes, X, Y and Z. So, A, B and C, these are the crystallographic axes. This is the set of the crystallographic axes, and the angle made by these axes are alpha, beta and gamma. Now, what is the crystal system or what is the lattice system? Crystal system refers to geometry of crystal and crystal structure, and which can be described by the set of reference axes or crystallographic axes. So we have to study in detail what are the types of crystal systems. So in all, there are 6 types of crystal systems. Crystal structures you have to study in syllabus. First one, isometric. Another name is cubic. Second one, tetragonal. Third, orthorhombic. Fourth, monoclinic. Fifth, triclinic. And last, hexagonal. So what is isometric? Here, all axial angles are 90 degree. That means alpha equal to beta equal to gamma equal to 90. And all axes are equal length. That means A equal to B equal to C. But in tetragonal, all axial angles are 90 degree, no doubt. But one axis is unique. That means A equal to B but not equal to C. In orthorhombic, all axial angles are 90 degree and all axes are different lengths. A not equal to B, not equal to C. In monoclinic, one axial angle is variable and all axes different lengths. Here A not equal to B, not equal to C, and here two angles are same, alpha equal to beta but not equal to gamma. In triclinic, all axial angles and axial lengths are invariable. That means unequal lengths, unequal angles. And in hexagonal, two equal axes in plane at 120 degree and third axis perpendicular and different length. Now, first one, cubic system. Here I have shown the wooden model for the simple cubic structure, and one example, very good example is halite salt is the cubic structure. And here all lengths are equal, all angles are equal. The structure is like this, and these are the symmetry characters. Then in tetragonal system, just now I told two lengths are equal but not equal to third. All angles are equal. Here wooden model I have shown, and the apophyllite is very good example of the tetragonal crystal system. Then next structure, orthorhombic crystal system. Here all lengths are unequal but all angles are equal. Here wooden model I have shown, and golden topaz is very good example of the orthorhombic crystal. The next structure is monoclinic crystal system. So here in monoclinic crystal system, all lengths are unequal, two angles are equal but one angle is unequal. So here wooden model I have shown, and this gypsum is very good example of the monoclinic crystal system. Then our triclinic crystal system. Here all lengths are unequal, all angles are unequal, not equal to 90 degree. Wooden model I have shown here, and orthoclase is good example of the triclinic crystal system. Then hexagonal crystal system. So here in all along with the three crystallographic axes, one axis is extra and this is not equal to the remaining axis, and the angles are likewise A1 to C 90 degree but this last one is the 60 degree. So one wooden model is hexagonal here for I have shown, and sapphire is very good example of the hexagonal crystal system. Now these are the schematics what I explained already. These are shown schematically, the lengths of the axis and the angles made by the axis. Then these are the schematics. Simple cubic, all are equal in length, tetragonal, then this orthorhombic, monoclinic, triclinic and hexagonal. It looks likewise. And finally, these are the structures, crystal structures. In short, this is the summary of the crystal structure. Crystal structure model, length and the angles. Here I have shown in summary. Last is the summary. So up to this is in this lecture. Then the next remaining part we will see in the next lecture.